بسم الله الرحمن الرحيم. نرحب بكم في المؤتمر العلمي الثالث الهندسة الكهربائية والإلكترونية وتقنية المعلومات في دورته الثالثة يوم الأحد والاثنين 30 و 31 من شهر أكتوبر. نرحب بالسيد وزير التعليم التقني والفني والسيد رئيس الجامعة الليبية الدولية، السادة عمداء كليات ومعاهد، السيد وزير البيئة والسيد وزير السياحة. نبدأ افتتاح مؤتمرنا بآيات من الذكر الحكيم.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين.
نبدأ الآن مع كلمة السيد عميد كلية التقنية الكهربائية والإلكترونية السيد علي السوري.
بسم الله والصلاة والسلام على رسول الله. نتشرف ونرحب بالسادة السيد وزير التعليم التقني والفني، السيد وزير البيئة، السيد وزير السياحة، السيد رئيس الجامعة الليبية الدولية للعلوم الطبية. يرحب بالسادة عمداء الكليات ومدراء المعاهد. يرحب بالسادة من الهيئة الليبية للبحث العلمي. نرحب بكل السادة البحاث الذين هم زهرة وجوهرة هذا المؤتمر بالأبحاث التي يشاركون بها. نرحب بكم في رحاب كلية التقنية الكهربائية والإلكترونية، وهي من أعرق مؤسسات التعليم التقني، حيث أنشئت سنة 1973 كمعهد متوسط للكهرباء، ثم في سنة 1985 كمعهد عالي للكهرباء، و2009 ككلية التقنية الكهربائية والإلكترونية. تخرج من هذه المؤسسة العريقة آلاف من الحملة الدبلوم المتوسط والدبلوم العالي والبكالوريوس التقني. نتشرف باستضافة المؤتمر الدولي الثالث للهندسة الكهربائية وتقنية المعلومات. هذا المؤتمر الذي تم البدء فيه منذ 3 سنوات، حيث أقيمت الدورة الأولى في الجامعة الليبية الدولية للعلوم الطبية، والدورة الثانية السنة الماضية أقيمت في جامعة بنغازي العريقة باستضافة كلية الهندسة، وهذه الدورة الثالثة. هذا المؤتمر اتفقت مجموعة من المؤسسات التعليمية العليا على أن تنظم هذا المؤتمر سنوياً، من الهيئة الليبية للبحث العلمي وجامعة بنغازي والجامعة الدولية الليبية للعلوم الطبية شركة تطوير للأبحاث وكلية التقنية الكهربائية والإلكترونية في بنغازي. ونتمنى أن هذا المؤتمر سيستمر سنويا. ننوه أن هذا المؤتمر أيضا في هذه الدورات السابقة كانت فيه مشاركات عديدة من مختلف دول العالم. أيضا سيشاركنا في هذه الدورة مجموعة من البحاث من العراق ومن مصر ومن بعض الدول الأخرى، بالإضافة إلى متحدثين رسميين سيكونون معنا بعد قليل على شبكة المعلومات الدولية. أكرر ترحيبي ونتمنى لكم أن تشاركونا، ودعمكم لنا في هذا المحفل العلمي الهام هو يرفع روح المعنوية لدى كل السادة أعضاء هيئة التدريس، بأن هناك مجموعة من السادة المسؤولين يهتمون اهتماما كبير بموضوع البحث العلمي. أكرر ترحيبي وأتمنى لكم طيب الإقامة بالنسبة لضيوفنا اللي من خارج بنغازي. الآن أستسمحكم بأن أقدم السيد وزير التعليم التقني والفني الدكتور فرج خليل بالحكومة الليبية لإلقاء كلمة افتتاحية. تفضل.
الحمد لله رب العالمين، والصلاة والسلام الأتمان الأكملان على سيدنا محمد خاتم الأنبياء والمرسلين صلى الله عليه وسلم. أما بعد، أيها السادة الكرام، أسعد الله صباحكم بكل خير. السادة الوزراء، السادة البحاث والباحثون والباحثات، السادة الحضور الكرام، أهلا وسهلا ومرحبا بكم جميعا. يسعدني ويشرفني بل لا تسعني الأرض من الغبطة أن أكون بين الباحثين والعلماء في مجال الهندسة الكهربائية وتكنولوجيا المعلومات، والذي هو مجال المؤتمر اليوم وتدور حوله أوراق المؤتمرين. أيها السادة، لا توجد وظيفة اليوم أشرف من تدريس العلم وتدارسه، لأنه وظيفة الأنبياء. ألا ترون أن النبي صلى الله عليه وسلم يقول: العلماء ورثة الأنبياء. السادة والسيدات الوزراء، السادة الباحثون والباحثات، السادة الحضور الكرام، نحن نعلم جميعا أن الهندسة الكهربائية وتكنولوجيا المعلومات أهمية بالغة في ازدهار الأمم، ومن هنا فإن الحكومة الليبية برئاسة السيد فتحي بشاغة تمتلك رؤية وطنية قد تكون طويلة الأمد سنطلقها ويرعاها مجلس الوزراء، وأن هذه الرؤى الوطنية ستضع الأسس التي ستمكننا جميعا من صناعة معادلات النجاح لليبيا على جميع الصعود، وسترون أنها ستؤتي أكلها بإذن ربها، وذلك من خلال تطوير قدرات الإنسان الليبي عبر منهجية رفع الكفاءة وبناء الخبرات لدى الكوادر الوطنية. إن هذه المؤتمرات تمثل فرصة جيدة تجمع نخبة من الخبراء والمهتمين لتبادل الخبرات والأفكار في تخصصاتهم المختلفة، كما أن هذا المؤتمر يحظى بدعم غير قليل من جهات محلية عدة ومشاركات محلية ودولية كثيرة، وهذا لا يدل على شيء إلا على إصرار النخب على النجاح والنهوض بالوطن. ونحن نعلم أن بلدنا هذا تخطى في مرات عديدة العواصف التي اجتاحته، وخرج قويا ثابتا رسوخ الجبال الراسيات، ولولا رجال كنا نعدهم من الأخيار لأصبح البلد كأمس الذاهب. ولعل من أهداف المؤتمر غير المنظورة هو إبراز الجانب الإيجابي، وأن ليبيا ساحة خصبة للمؤتمرات والندوات وورش العمل ومعارض الكتب والتبادل الثقافي والمعرفي. السادة الكرام، يقول علماء التنمية البشرية إن أفضل أنواع التنمية بناء الإنسان لا بناء الجدران. ويقول مالك بن نبي رحمه الله: العالم العربي والإسلامي لا ينقصه مبدأ التنظير، وإنما ينقصه مبدأ التطبيق. فمبدأ التنظير موجود في المعاهد والكليات، ولكن التطبيق قليل جدا. ولكنني أرى اليوم أن التطبيق موجود في عدة نماذج في الجامعات الليبية والمعاهد. أيها السادة الكرام، حتى لا أطيل عليكم، أود أن أختم بأن أنقل لكم اعتذار رئيس الحكومة عن المجيء لظروف خارجة عن الإرادة. أتمنى لكم التوفيق والنجاح، والسلام عليكم ورحمة الله تعالى وبركاته.
والآن مع كلمة السيد رئيس المؤتمر الدكتور فرحات الشطار.
بسم الله الرحمن الرحيم. بالنيابة عن اللجنة العليا للمؤتمر، أرحب بكم جميعا حضورنا الكرام بالدورة الثالثة من المؤتمر. المؤتمر الدولي للهندسة الكهربائية وتقنية المعلومات. تشكلت الفكرة من التقاء ممثلين عن كل من المؤسسات التالية: كلية الهندسة وكلية تقنية المعلومات من جامعة بنغازي، كلية تقنية المعلومات بالجامعة الليبية الدولية، كلية التقنية الكهربائية والإلكترونية بنغازي، شركة تطوير للأبحاث الهندسية وتقنية المعلومات، وهيئة أبحاث العلوم والطبيعة والتكنولوجيا. ونتج عن هذا الاجتماع اتفاقية بين المؤسسات المذكورة لتأسيس هذا المؤتمر منذ حوالي 3 سنوات. أهداف المؤتمر هو تعزيز التواصل بين المؤسسات العلمية، تأسيس منصة علمية ليبية ترتقي بالمعايير العالمية، وتقليص الهوة بين الشركات والجامعات. ها نحن الآن نفتتح الدورة الثالثة من المؤتمر باستمرارية وثبات واضحين، محققين بعض أهداف المؤتمر التي تصورها مؤسسو هذا المؤتمر: التواصل بين المؤسسات العلمية من خلال تحضير المؤتمر في تطور مستمر. تمكنا من نشر الورقات المقبولة في سكوبس، وهي قاعدة بيانات عالمية للورقات ذات الجودة العالية، وكان عددها 45. أصبح المؤتمر منصة تصل بين الباحثين المحليين والدوليين. هذا المؤتمر نجح بصورته الحالية من خلال عمل لجان المؤتمر، على رأسها اللجنة العليا للمؤتمر واللجنة العلمية واللجنة التحضيرية التي أدارت المؤتمر في وقت انعقاده. الشكر موصول طبعا للداعمين لهذا المؤتمر: AGYA German Academic Europe، وشركة المدار الجديد، وشركة ليبيا للاتصالات والتقنية، وشركة ليبيا تك. الشكر موصول لهم لدعمهم هذا المؤتمر، وموصول أيضا للجان المؤتمر التي عملت بجدية وانضباط حتى ينجح الدورة الثالثة من المؤتمر، وإمكانية استمرارية هذا المؤتمر لانعقاده في دورات قادمة. والشكر موصول أيضا لإدارة الكلية. أنا أشكر الكلية نيابة عن اللجنة العليا، إدارة الكلية التي بذلت الكثير من السعي لإنجاح هذا المؤتمر. وشكر موصول طبعا للبحاث الذين قدموا ورقاتهم لعرضها ونشرها بالمؤتمر، الذين أثروا المؤتمر وسيثروا المؤتمر في جلساته التي ستعقد بعد حفل الافتتاح. اسمحوا لي نشكر أيضا المتحدثين باللغة الإنجليزية. We would like to express our gratitude to the sponsors of the conference, Arab German Academic Europe, المدار الجديد، Libyan Telecommunication and Technology, and Libya Tech. We thank you all for your generous support which makes this event possible. الشكر موصول طبعا لكافة الموظفين في الكلية اللي ساهموا في إنجاح هذا المؤتمر. أقدم الكلمة الآن لرئيسة اللجنة العلمية لتطلعنا على مسار العمل العلمي في المؤتمر. شكرا. الدكتورة كنت زي أسف ما عرفت.
محمد.
السلام عليكم. بسم الله والصلاة على رسول الله. السلام عليكم. أولاً أرحب بالضيوف والحضور والمشاركين. طبعاً نحن نقدم برزنتيشن أو عرض مرئي مختصر للإنترناشونال كونفرنس أوف إلكتريك إنجينيرينج أند إنفورميشن تكنولوجي. طبعاً ما في جاي نعاود هذه الشركات اللي هي المنظمة أو المؤسسات المنظمة للمؤتمر. هنركز على الجانب العلمي للمؤتمر. طبعاً الكونفرنس تراك يتكون من تو بارتس أو من جزئين اللي هو الإلكتريك and electronic engineering والكمبيوتر and information technology. زي ما تشوفوا مش هنتطرق المواضيع كما هي واضحة قدامكم عشان نستمر. طبعا يهمنا نحن اللي هي الإحصائية العامة للمؤتمر. كان عدد الأوراق اللي هي submission paper كانت 101 ورقة علمية. عدد الأوراق المقبولة في المؤتمر كان 45 ورقة. acceptance rate كان 45%. الريفيوز كانوا عندنا الريفيوز كان عندنا 231. المقيمين الداخليين كانوا عندنا او المحليين كانوا عندنا 101. الانترناشونال ريفيورز او المقيمين الخارجيين كانوا عندنا 54. كان المجموع الملاحظات من المقيمين الخارجيين 126 ملاحظة. من المقيمين الداخليين كانت 105 ملاحظة. وطبعا هذا يعتبر مؤشر جيد ان مؤتمرنا فعلا ناجح كانترناشونال كونفرنس. بالنسبه للبيبر الستاتستيكال او الاحصائيات الاوراق العلميه، كان عدد الاوراق العلميه الانترناشونال او الاوراق اللي هي دوليه كان عندنا 39 ورقه استقبلها المؤتمر. الاوراق المحليه كان عندنا 62 ورقه. عدد البحاث اللي هم انترناشونال او دوليين كانوا عندنا 56 واستقبلنا من البحاث الداخليين 132 باحث. طبعا الاحصائيات هذه كانت عن طريق البرنامج اللي استخدمناه الالكترونيا اللي هو او التولز اللي هي ايزي تشيرز. والاحصائيات الموجوده عندكم كانوا من خلال هذا البرنامج. طبعا هنا عندي اللي هو الاوفر اول ايفالويشن بروسيسنج، كيف تمت عمليه تقييم الاوراق. تم استقبال الاوراق اول شيء، ومن ثم تمت عمليه الريكوست ايفالويشن ان نحن بعثنا ريكوست للمقيمين، فكان عندهم فورم للتقييم. بعد الفورم للتقييم طبعا تم اجتماع اللجنه العلميه. طبعا العمل كله كان الكتروني، فكان عندي الديسيجن او الستيت اوف ريفيوينج زي ما موجود عندكم. النتيجه هذه كانت عن طريق البرنامج. كان زي ما ذكرت 45 بيبر مقبوله، وكانت عندي الريجكت نتاعي 56 ورقه، بالرغم من ان كان عندي 56 ورقه مرفوضه. كانت بعض الاوراق جيده، ولكن نظرا لالتزام المؤتمر مع منظمه AGYA ان نحن ناخذ 45 ورقه علميه. طبعا الكونفرنس بروجرام حيكون عندنا على يومين كما هو موضح عندنا. الاوراق المقبوله سيتم نشرها في اللي هي الاي تربل اي في الاي تربل اي ديجيتال لايبرري، وهذا باختصار ما قامت به اللجنه العلميه. ممكن البرزنتيشن قصيره، لكن عمل اللجنه العلميه كان على فتره تقريبا 6 شهور، ونتمنى بصراحه التوفيق للباحثين، وشكرا للحضور. طبعا على بركه الله نبدو في برنامج المؤتمر بتاعنا. طبعا زي ما موضح عندكم في الكونفرنس بروجرام حنبدو الافتتاحيه بتاعنا. ربنا نعتذر حنعطي بريف للكينوت سبيكرز. على بركه الله نبدو البرنامج بتاعنا. حنعطي بريف للكينوت سبيكر الاول. Welcome, Dr. Lobna.
Welcome, Dr. Kins. How are you? Should I start?
Welcome, all of you, keynote speakers. Actually, I will give you a brief introduction to Dr. Lobna Saeed. She is a senior member of IEEE since 2020. Is a full-time associate professor at Faculty of Engineering and Applied Science, Nile University. She is co-principals, integrators of 2 nationality-funded research projects in Egypt. Also, she has some research projects in smart integration of Internet of Things. Also, she is a member of the Arabic German Young Academy of Science and Humanities. So, welcome, Dr. Lobna, to give your presentation. And we are happy to be with us.
Thank you so much. Can you hear me now? Can you hear me? Can you hear me? I was just making sure that everyone can hear me. So can you hear me? Hello, can you hear me?
Yes.
Okay, perfect. So good morning, everyone. I'm actually very proud and honored to be here today for this wonderful conference. I'm going to give you a okay. Can I start now?
Yes.
Yes, I can hear you. So can I start? Hello. Can everyone hear me?
We are hearing you.
Okay. So, I'm going to give you a brief about fundamental of fractional calculus and how can we integrate this concept into different applications in electrical engineering. As Dr. Ken said, I'm Lobna Saeed. I'm Associate Professor at Nile University and Director of Microelectronic System Design, Master Program at Nile University, and I'm also an AGYA member. The outline of this presentation will actually cover the fundamental of fractional calculus to give you brief how can we integrate this calculus into applications, and then moving forward to different electrical engineering applications, which is the main focus of the conference. Okay, what is actually fractional calculus? What is the meaning of fractional calculus? Actually, it started with a very funny story. Now we are all having social media, we have WhatsApp, we have emails, we have lots of ways to communicate with each other. So, but back then, at the time of Leibniz and L'Hopital, we didn't have such things. We actually have only mails, you know, see this regular mails. So the concept or the science of fractional calculus start with a letter from L'Hopital to Leibniz. He was asking him, what about the fractional, the derivative is fractional with order 0.5. So Leibniz start to think about it. Okay, so if this happened, if we could make a derivative with order 0.5, this will lead to a paradox from which one day useful consequences will be drawn. And Leibniz is considered the godfather of fractional calculus. Fractional calculus is the generalization of the ordinary differentiation and the integration to an arbitrary non-integer order. And actually Leibniz was correct, because currently fractional calculus is the most cited. If we take back the last 10 years, we will find work in fractional calculus is one of the most trending areas in research in different fields. We will go back on time. Long time ago, it was the things are dominating the research was static modeling, which is algebra and geometry. But before 1695, the dynamic modeling were dominating, which is differential and integral calculus. This is a normal calculus we know. But after 1695, fractional order modeling started to appear. So now you can think about it, why you didn't hear a lot about it, because there was a wide use of integer model, because there was absence of approximate solution for the fractional world. So why should I go to the harder application when I have a simpler one? And when some definitions are used to define the fractional order model, such as Granville, Lettenkopf, Riemann, Loville, and Caputo, the fractional order start to appear. So we were all working in this domain, but the fractional calculus is the generalized domain. So why should you stuck with a point where you can work with a domain? To make it clearer for you, what is the fractional calculus? Let me start with a simple case, which is the differentiation of the sine. Of course, we all know the differentiation of the sine omega t is cosine omega t. The sine and the cosine is only phase shift 90. This is how can we differentiate sine into cosine. But did anyone ask himself exactly why or how the sine changed into cosine? How this happened exactly? How can we change the sine into cosine? How this phase shift happened? We actually didn't think about it before. We actually didn't think about it before, how the sine is conveyed to cosine, how this phase shift happened. But let's talk about the fractional derivative of the sine. And it will maybe interpret how the sine changed into cosine. As you can see here from the MATLAB simulation, these are the fractional derivative of sine omega t. As you can see here, we are moving. We have different phase shifts. So what is happening? The fractional calculus interpret how the sine changed to cosine, and this interpretation was not actually in mind of mathematicians or engineers before, because you only know that you have sine, which is converted to cosine, and then back to sine again in the second derivative. But what about the surfaces? Is there anything between this derivative? Yes, there is. And if we look at 3D, this is the fractional order derivative from 0 to 1. And you can see, so the fractional order derivative is about the continuation, which was not addressed before. So we have infinite number of surfaces we can work on, but we are also stuck with 2 points, 0 and 1, the no derivative and the first derivative and the second derivative. But in between, there's something. There's surfaces, there is different phase shifts. So it is not just moving from 0 to pi/2 phase shift. No, we have different phase shifts. We can have phase shift alpha pi/2 according to the order of the fractional derivative. And if we think about the fractional order integration, it's the same concept. If we would like to integrate y equal t, so it will be t squared over 2. How the t is changing to t squared over 2, how this derivative happens? Simply, it's not just a discrete derivative, it's actually a continuous derivative. So what is in between? You can see the lines in between, y equal t and y equal t squared, the first derivative y dash equal t squared over 2, the continuation of these surfaces. So I'm now showing you some FPGA implementation. We actually would like to always digital, we do as an engineer, we do digital implementation for the fractional order derivatives because this is engineering. So this is FPGA implementation of the derivative. We implemented these derivative on FPGA. As we can see here, this is an integration. You have, we integrated two functions, square function and sawtooth function. Of course, the first order integration for the sawtooth function is a polynomial, as you can see, is a quadratic. But how can we reach this quadratic? As you can see here, when we do integration, the first row is integration 0.2, negative 0.2, of course, and we have here, we approaching that quadratic formula. And for the square, we have actually a sawtooth. So it's not just the sawtooth, it's actually, it's formed till we have reaching the sawtooth. Of course, the complete sawtooth will be reached when the order of integration is -1. So how can we use the fractional calculus? We have different applications for fractional calculus. It exists in the control theory, it exists in mechanical engineering, chaotic systems, control, and bioimpedance field, and electromagnetics. Of course, now all the complete science can be regeneralized according to the theory of fractional calculus. We were actually working on only special case. All the science we know is only special case from the domain, the general domain of the fractional calculus. Okay. One of the revolutionary concepts created by the fractional calculus is the concept of the fraktance device. What is the fraktance device? If we got to take Laplace transform of all elements we know, we have impedance Z equal K over S power alpha. Of course, now alpha, this is the new item introduced by the fractional calculus, which is the order alpha. And what we know as an electrical engineers, we only know 4 components. Which are these 4 components we always work with? The resistor, the inductor, the capacitor, and the frequency dependent negative resistance. This is what we all know and work with as an electrical engineers. We only know 4 points. But you see, these are special cases from the general fraktance device, which could be happen here. It's an intermediate element. We have infinite number of elements that we can work with actually as an engineer. So how can we use of these elements? Simply, it's about phase shift. If you have an inductor, you have phase shift between V and I negative pi/2, and the capacitor, it's 90. But what about these intermediate elements? These intermediate elements have a phase shift between the volt and current is actually alpha pi/2. So new possibilities could happen, new generalization of many things happen. These elements, what is the nature of these elements? Actually have a combination between here, this element in this area, it have a combination between capacitor and frequency dependent negative resistance, and the intermediate element between the resistor and capacitor. When we approach the capacitor, it will have a capacitive nature. When we approach the resistor, it will have a resistive nature. So these new elements can make a revolution in many electric circuit applications. So the question is, are these applications or this fractal device exist as an off-the-shelf device currently? Unfortunately, not yet, because it is not easy to do this this fractional device. So, but according to research, as we can see here, the researchers started to implement this device from 1959 till currently. We have different implementation. First, we started with emulators. The emulators is electric circuits actually that mimic the behavior of this intermediate elements. And people try to do fabrication using electrochemical component, and people try to do it on silicon using fractal structure. And of course, the active implementation of these elements, which is actually one of the hot topics currently in the implementation of fractional order device, because people are trying to do a tunable device, which means you can tune the order, because as you can see, we have a fractional element from order 0 to order 1 to order 2. So we can tune this element to have a specific order, and this order means phase shift between a device which have a phase shift between the volt and the current by alpha pi over 2. So why to do approximations, or why to do emulators? The one I showed before, because actually we cannot still buy this element from the market. It's not exist as an off-the-shelf circuit component. So till this existence, we have to approximate or do emulators for this device. Okay, and why again we do approximate? Because it's still at this moment the methods for integer differential equation are better known and widely available. It doesn't mean the methods for fractional order does not exist. It exists, but people are still more familiar with the integer order one. And it's easy and cheaper to do a hardware and integer transfer function, which is correct. It's easier and cheaper. So as long as the approximation order increase, the error decrease, but it will be on the expense of the hardware realization. So we would like, we have now a trade-off. We would like to have approximated transfer function for this fractals device, and we don't need with a reasonable error for us. And of course, we don't need huge hardware realization, because we don't need to have accuracy on the expense of the cost, or the cost on the expense of the accuracy. So it's a trade-off. So I will show you a brief of or summary of what are available approximation technique to approximate this fractals device. Of course, what is this fractal device? How can I know that I have a good fractal device? When we have a constant phase shift between volt and current. So practically, I need this constant phase shift to be along the complete frequency range from -infinity to infinity, which is the usual capacitor and the usual inductor. If you measure the impedance of the capacitor, you will have a phase shift of pi over 2 along all the frequency range. So this is the target. Let's check one of the approximations. One of the most famous approximation Cron toolbox, which is available on MATLAB, is OSTA-loop approximation. As we can see from the MATLAB simulations here, increasing the approximation order, like the first one is actually n. When we increase the approximation order, the frequency range where we have a constant phase is actually increasing. But we can see here after approximation order 8, the frequency range is not enhancing. So this is a drawback in OSTA-loop. We cannot have even further increase, but an approximation order doesn't have any effect on the frequency range and the constant phase element. So I think it is not OSTA-loop. You can reach 8, and after that, no need to make more implementation or complicate the hardware. You don't need to do this. Okay. And here, as we can see here, this is if we do an inductor, and this if we do a capacitor, because of course you have a pi over 2 shaft or a negative pi over 2 shaft. So negative alpha pi over 2 and positive alpha pi over 2, according to which element you are trying to implement. One of the most famous approximation technique is the Matsuda approximation, and you can see here Matsuda increasing the approximation order, increase the frequency range where you have a constant phase element. So the key here is to do a constant phase element along the approximation. we actually fabricated, we do a fabrication for the fractional order element. As I told you before, we have different approximation techniques. I only showed you two of the most common one, but we have another one called VALSA. This is circuit approximation technique for this fractional element as well. As you can see here, this is how we model the fractional order capacitor, and this one and this chip is the approximated the fabricated element we created. As you can see here, we are searching for a constant phase element along a specific frequency range. As you can see here, this is the exact phase. It should be like this, like the red line, and the dotted line, the blue and black dotted lines represented the approximation technique. We used Matsuda, which is the most commonly used, and VALSA. This is a circuit approximation for alpha equal 0.4. So we should have a constant phase is actually -36, and we could achieve an error percentage 7% for Matsuda and 10% for VALSA. So Matsuda is actually is a better approximation than VALSA in this application. And the frequency range, it's actually controllable. So according to your application and what do you, how in which range do you need this element to work properly, you can use a specific approximation according to this. And of course, it is not going to work in all frequency ranges because this is an approximation and not an exact one. Okay. One of the interesting information about any system, it has to be stable. If you are working in control, if you're working in filters, if you're working in any electronic component, you need your system to be stable. What the stability means in electrical engineering, you only know the S domain, and you don't want any route system routes to be in the right half plane, and you want all your routes to lie in the left half plane. And of course, if any routes fall in the J omega axis, it will be oscillatory, but it will be oscillatory stable because it's actually the J omega axis here. So, and this is the integer order systems we all know. How about fractional order systems? Is the stability of fractional order system could be achieved, or actually how can we achieve this? Because you have now transfer function with order like 10 over 5 over 2, 5 over 2. So how can you get the roots for something like that? It's very simple. We just write actually the transfer function in this form. We make it, if you have s to the power 0.22, we write it s to the power 2 over 10, and then transfer this function into a new domain. It's called the W domain. What is the W domain? The W is equal s to the power 1 over m. So now you have a W over k. So we transferred the system into another integer order system we are all familiar with. And then we get the roots in this new system and then convey it back to the S domain. So it's easy. But of course, when we upgrade the system, the fractional order systems to the integer order one, not all the roots in this new domain is actually have a physical meaning or can be conveyed back to the S plane. You can mirror it back to the S plane. So here, any roots lie in the non-physical region in the W plane doesn't have an image back at S plane. So where is the S plane? So this S plane at the right hand side is actually only in this physical area, as you can see this physical area. So as simple as that, here and at this stable region, these are the stable areas. So this part is conveyed here in these two regions, and this part, the instability, is conveyed here in these two regions. And if you see these dotted lines, this is the J omega axis. So now you can, if you have the W plane, you can understand where exactly is your stable region. Of course, the non-physical doesn't have any image back to the S plane, so we are fine. Now I'm going to show you MATLAB simulation of a system. Here we are changing alpha here. You see, as long as all this is a non-physical, as long as we don't have roots at the non-physical region at the W plane, it has no roots here. See see how the roots start to enter the S-plane when you actually have a roots started to enter these regions. And this is how you can judge the system stability in the fractional order domain. Okay. So now I give you a mathematical brief in order to let you understand how can we what is a fractional calculus, what is the fractional element, and what it could do to our research in general. Of course, research in circuits and systems in the fractional order domain, it is actually considered an interdisciplinary topic because it serves many areas of application in the electrical engineering. It exists in medicine, it exists in physics, it exists in control systems, it exists in signal processing, chaos theory, bioimpedance. I'm actually focusing here in this presentation on only 3 applications: bioimpedance, chaotic systems, and electronic circuits. Electronic circuits will be merged with the bioimpedance concept and also chaotic systems. Okay, what is bioimpedance exactly? You know, if you have a tissue, this tissue, biological tissue, fruits, vegetables, any biological tissue, and if you pass current through this biological tissue, it will resist this current. The applied stimulus, we will have an impedance which resists the applied stimulus. So any tissue, any living tissue, can be regarded as an electric circuit. So our tissue, our skin, if you have an apple, if you have any biological tissue. So this is called the bioimpedance. So the bioimpedance is a concept which is the impedance, the bioimpedance. The impedance is how our tissue resists to any applied stimulus. Okay, bioimpedance, so it gives us an impedance, but this impedance is actually different according to tissue composition, according to tissue structure, according to the health status of the tissue, according to the applied signal frequency. As you can see here, this is a tissue, and this is the cells itself. If we have current flow inside the tissue at low frequency, the current flow like this in the fluids in between the cells, as you can see here. So the information we could achieve reading the bioimpedance at low frequency is different from the information we could achieve or we could have from measure the impedance at high frequency, because at high frequency the current penetrates the cell, as you can see here. It's completely penetration inside the cell itself. So we could measure the bioimpedance at a huge frequency range, and we could extract multiple information about the tissue itself. How can we use this bioimpedance? Bioimpedance is used in many applications. Everyone saw it in the device that measured the percentage of muscles mass and fat mass and body water. Of course, you're all familiar with this device. You just stand up and put your 2 thumbs here at the device, and it just gives you a paper, and this paper tells you how you have do you drink water, good fat mass and in your body. So it's actually really important. Red blood cells, when we store the red blood cells for a long time, does this affect the quality of the stored blood? Yes, it's actually affects the quality of the stored blood. Can we use this blood later on? Sometimes no. And the bioimpedance actually could give us a solution for this without destroying the samples. It's the concept you could differentiate between the healthy and the infected fruits. Of course, sometimes you have an apple and it looks visually very good. When you open it, it's just rotten or has some problems inside the apple. This could be achieved by the bioimpedance concept without any penetration for the fruit and vegetables. Of course, you can also get to know the freshness, the freshness of fish and the freshness of meat using the concept of bioimpedance. And we also use it to do a gross monitoring till the ripening moment for any fruits and the vegetables by monitoring the bioimpedance change while the plant is actually growing. And this concept is actually very important in precise agriculture, because people are, or most of the Arabian countries, people are actually do agriculture by experience, But sometimes we need scientific methods to determine what is the exact or the perfect ripening moment, because sometimes or at some point we are going to not to have this experienced farmer, so we must use technology in farming. And also it could tell us the concept what happens if we have a freeze or chill fruit damage due to storage, because sometimes we just put our food in the refrigerator, but is it valid for eating after this? What does it lose when we do freeze or chill to our food? How can we measure the impedance? We actually can measure the bioimpedance using two items, either portable devices or bench devices. Portable devices have two actually items, either direct method by impedance analyzer or indirect method, which is a circuit based, and then we do post processing using optimization techniques or AI algorithms, or bench devices which also contain impedance analyzers, and then we can use the impedance analyzer curve fitting technique, or we can do post processing using optimization techniques. Why there is a problem with an impedance analyzer? Because actually they are costly, they cost a lot. We have the SB150 and we do our experimental work using this SB150, and it's costly. Okay. How the fractional is integrated here, I told you we are considering the tissue as an electric circuit. So these are the models that represent any tissue. The Cole model, which was introduced at 1940, is the most widely common model that represents any tissue. This model is actually valid for human tissues, valid for animal tissue, valid for fruits and vegetable tissue, and it was started at 1940, followed by the Haydn model, which was an integer order model, and we transferred it to a fractional order model, and it fit better than its integer order counterpart. And the double shell model and Dias model and the respiratory system model, you can see that we are actually starting modeling the bioimpedance since 1940 using fractional order modeling. And here are some measurements we did for several fruits, banana, cucumber, lemon, and others. And we checked which model. Actually, we use the SB150, the bench device, to measure this bioimpedance. And if we can see here, this is actually how the double Cole and the single Cole are better fit visually for these for presenting or actually assembling these tissues. We have actually two kinds of research in this field. The first one is to collect impedance measures using the benchmark device SB150, and then do several optimization algorithms by meta-heuristic optimization algorithms, plus selecting all possible models, and to determine which model is best suited for these fractional order tissues, and determine the best optimization algorithm. This is a very trendy application, and in this area of bioimpedance. The other trendy application is to interpret what is happening real in the tissue using this electrical impedance. And we did some experiment, which is heat freeze for carrots. We had 6 fresh carrots, and we measure the impedance when they are fresh, and then we heated 3 samples and freeze the 3 samples, and we would like to know what happened inside the cell, inside the tissue itself after heat and freeze, and how this affecting the bioimpedance, how this is changing in the cellular structure of the carrot affect the bioimpedance, and how this is conveyed to the measurements. And if you can check here, the right hand side is actually showed us a temperature variation while freezing. When you freeze the tissue, it's just the liquid inside it just disappears. There is no liquid, just hard as it's solid hard, and the impedance is actually increasing while decreasing the temperature. On the reverse is happening when you heat the tissue. When you heat the tissue, the cell wall that is actually surrounding the cell, what happened to the cell tissue? The cell wall is actually destroyed, and this tissue is softened. So the impedance, the amount of liquids increases, and the cellular structure is completely destroyed. And as you can see here, increasing the temperature decreases the impedance. And this is some correlation we could understand about the impedance. Now we are going to talk about electronic circuits. Oscillators, of course, we all know oscillators. Oscillators is a generation of periodic signals such as sinusoidal, triangular, square, whatever signal is periodic. So this is an oscillation. And you could, you could do it like in current feedback operational amplifier, op-amp, OTRA. What we are actually do with fractional calculus, we use the oscillator circuit to create a portable device. To use it, actually, this is very cheap to use it instead of our impedance analyzer. I will actually finalize this and sum up. What we did, we actually embed our fruit inside an oscillator circuit, and then measure the frequency of oscillation more than one time. And then we actually got these measurements and inserted it into the differential equation, and we solved this equation, and we could extract the parameter. So the oscillator circuit actually could work as an impedance analyzer. So how can we make sure that this statics will work? Actually, we compared our results using the measurements from the impedance analyzer. The benchmark device we have was SP150, and we could extract the correct parameter of the tissues with a percentage of error 3.5% and 4% and 5.5%. So we could achieve a cheap portable device, could be used and could be actually used on the fruit, and could be implemented on a chip with a very minimum cost. So I don't know if I still have time or not. Should I go to another application or? Hello, can you hear me? One of the interesting applications in also fractional order systems is the chaotic system. Chaos in general is a state that if you change the initial condition of the system, you will have a major changes in the system itself. So actually, this is how chaos is. What is interesting about the chaos is you can use it in encryption systems, because it's not easily to be interpreted. It's not easily to be regenerated. So you can use it in pseudo random number generator, and it's actually very immune to brute force attack and encryption system. We have different kind of fractional order chaotic systems, and these chaotic systems actually can be controlled by the fractional order system, have extra degrees of freedom, more complicated, which is very important in when you do any encryption or you do pseudo random number generator. You want it to be hard to be decrypted. You want to be hard to be attacked. You want to be hard to be predicted. So fractional order chaotic system created this hard equation. It increased the system performance, increase the system parameters, provide more degree of freedom, increase the complexity, give you more varieties. As you can see here, this is different implementation of fractional order system. This is the integer order system, just the V shape. We can do asymmetric shape. We can do different shapes using fractional order system. More complicated systems could be achieved. Lots of stuff could be achieved using fractional order in chaos and in other applications and in control systems. To sum up everything, fractional order is generalization of integer order systems. Fractional order could regenerate all the electric engineering or mechanical engineering or control engineering. All the engineering disciplines we know could be generalized, could be re-implemented, could be redefined using the series of fractional calculus. It's actually implemented in interdisciplinary kind of research, and it's one of the hot area currently. And I hope I'm not taking too much of your time, and I hope you enjoyed the presentation. Thank you so much.
We cannot hear you.
Lobna, there is no questions from the participants. Before introduce Dr. Thank you so much, Dr. Lobna. Before introduce Dr. Nada, we have to express our thanks to AGYA to support and sponsor this conference. And now we go through the next presentation to Dr. Nada. I have to give a brief bibliography for Dr. Nada. Dr. Nada Darra, she is Associate Professor of Food Safety and Technology. She has got her master's degree in the food analysis and safety from the Faculty of Health Science, Beirut University. Her research project focuses on the food safety and technology. She addresses some topic from different research institutions. Also, she is a member of Arabic German Young Academy of Science and Humanities. So now the talk to Dr. Lobna, and thank you in advance, Dr. Lobna. So you have to start, and thank you very much.
Thank you so much. Can you hear me first? Hello, can you hear me?
Yes.
Yes. Yes.
Okay, perfect. Thank you so much, and good morning from Beirut, Lebanon. I would like really to express my thanks for the organizing committee for this kind invitation to participate as a keynote speaker in this international conference. And indeed, as you mentioned, so I'm AGYA member, and I'm proud to be an AGYA member, and I'm as well associate professor in food safety and technology. So definitely you are wondering how come I'm a food specialist and I'm being actually invited to this event, because when we talk about technology, technology is multidisciplinary, and we have technology in IT, we have gene technology, we have electrical engineering technologies, and definitely we have food technology. So today I'm going to talk about decontamination of spices and herbs using hurdle technologies. So I'm going to define the hurdle technology that we use in our actually research work. But first, I would like to mention why did we have chosen this matrix specifically. So spices and herbs, they were chosen in our research project because they are considered as essential food components of human nutrition. They are being used as flavoring ingredients, and they are being used as well for different medicinal applications. So they are highly utilized as well as natural preservatives in food because they possess important antioxidant properties, antimicrobial properties, anti-inflammatory properties, as well as anti-cancer properties. So we all know that spices, they are low in content, so this makes them actually stable for a longer period of time. However, many research studies have shown that spices are prone to microbial proliferation. So they can be highly contaminated with microorganisms, ending up by contributing in many foodborne diseases and foodborne infection. So spices are shown to be prone to 3 types of contaminants. We have physical contaminants, for example, when you see any foreign body, a hair, or any kind of physical contaminant in the spice. We have also chemical contaminants, and here I'm sharing the Daily Star publication on one of my research work, screening multi-mycotoxins in spices commercialized in the Lebanese market. This work has been done in collaboration with the research center in Italy. So we have shown in Lebanese spices and herbs a multi-occurrence of mycotoxins. Mycotoxins are known to be carcinogenic. So also among the spices contaminants, we have the biological contaminants. Specifically, we are talking about bacteria, viruses, fungi, and yeast and molds. And here, as you can see in this food chain, so the contamination of spices can occur starting from the pre-harvesting level in the field, passing to the storage, the post-harvesting level, all through the transportation and the processing, and passing to the retailers, and finally reaching the end consumer. So we all know that the food should be safe from farm to fork. So it's our right as end consumer to be served a safe food, a food free of harm. Actually, it's a top priority for us to maintain the safety all along the food chain. So in Lebanon, several studies, they have investigated the microbiological contamination of marketed spices and herbs. So here I'm showing some of the studies, such as Dibs and Luca 2016, Hassan 2022, and Makhloud 2019, who have shown a high load of total aerobic mesophilic bacteria, sulfite-reducing anaerobic bacteria, Clostridium coliforms, E. coli, and yeast and mold, and many spices and herbs collected from the Lebanese market. And this kind of contamination is creating a border rejection, because we all know that it's very important actually to sell in the Lebanese market a safe food, but it's also important to export safe food abroad, and this will enhance the international trade, okay? So as you can see here on the left side, I'm showing the rapid alert system for food and feed, who's showing a notification of cumin imported from Lebanon to Germany. Okay, so this was actually on 5/7/2018, and the main reason of rejection was the presence of Salmonella, which is a pathogenic bacteria in cumin. On the right side, I'm showing the FDA import alert list, so the United States Food and Drug Administration import alert list, where we are showing as well falafel ready mix contaminated with Salmonella exported from Lebanon to the United States. So there is an urgent need actually to decontaminate spices and herbs in order to make them easy to get access and to outreach to external market and facilitate the international trade. So to do this, we have used many technologies. So some of these technologies are conventional and some others are new. So I will start with the gamma irradiation. So it's based on electron beam accelerators emitting ionizing radiations called gamma radiation. And this irradiation has shown to be very promising in decontaminating spices and herbs. It's currently used in the United States for spices and herbs, and the dosage can be used up to 10 kilogray. In Europe also, it's being used for decontaminating spices and herbs, but there is a mandatory declaration on the label. So as you can see on the left bottom side, there is this symbol in green. It's called Radura symbol. So when you irradiate spices and herbs, it's an obligation to declare this on the label. And this will make the product poorly accepted by the consumer, because some consumers, they actually confuse between radiation and irradiation and radioactive isotopes, and this will decline the acceptability of this kind of product among the consumers. Additionally, from a chemical point of view, the irradiation is shown to release cyclobutanone, which is a carcinogenic compound known as well by its genotoxicity and cytotoxicity. So this photo is showing actually me and the director of Irradiation Center in Amman, Jordan, where we were actually conducting some trials on irradiating za'atar or thyme mixtures, so Lebanese thyme mixtures, because we were planning to compare this kind of technique with other emerging technologies for decontamination. The second treatment that I'm going to show is the heat treatment. So we all know that heat treatment is very well used to decontaminate bacteria, because it's known by its effect on killing bacteria. And the heat treatment has one disadvantage, is that it's energy consuming, because we are relying on a long period of time for a high temperature. And here I just made a trial where I autoclaved the cumin. So you can see in the photo, before and after autoclaving 121 degrees Celsius for 30 minutes, we ended up by fully browning the color of the cumin. So we have a big difference in color, and this make the product unacceptable among the consumer. So that's why heat treatment for a long period of time at a high temperature is not adequate for spices. We all know that we use the spices for their flavors and for their color, and essential oils responsible on the flavor, they are highly susceptible to temperature. So if we treat at a very high temperature, we will end up by losing the quality of the product, the color and the flavor, and definitely it's nonsense to decontaminate from one side. Okay, we are able to produce a safe product, but if we destroy the quality, no one will use the product. So that's why this option was not the adequate one for spices and herbs. That's why we worked on developing a steam treatment called intensification of vaporization by decompression to the vacuum. And here I would like to thank AGYA for supporting this research work through a tandem project this year. So I'm currently collaborating with Professor Nicolas Loua, the owner of this patent. So you can see also on the right side at the bottom, we were making some trials on spices and herbs. The idea of this treatment consists of applying a high steam pressure where we reach within a saturated steam pressure, where we reach within a very short period of time, like within a few seconds, a very high temperature, but the time of exposure to the high temperature is very short, and then it's followed by a rapid decompression to the vacuum. So what's killing the bacteria in here, in this kind of treatment, is not the high pressure. It's rather it's not the high temperature. It's rather the rapid decompression to the vacuum, who allowed a complete deterioration of the membrane of the bacteria and a full destruction of the bacteria. What is good also about the treatment is that it's chemical-free, environmentally friendly, and so far it preserves the quality of the product color-wise and flavor-wise. So after making some trials, we send the sample to a research center in Germany, and currently they are checking the essential oil profile and the color to make sure that this treatment is a good treatment for the decontamination of spices and herbs. The next treatment that I'm going to talk about is the fumigation with ethylene oxide treatment. I can tell you that it was one of the treatment, the mostly used one in Lebanon, because it was shown to be very effective. But as you can see on the right side, that the ETO gas treatment has been banned under European legislation in 2021 because it was shown to release carcinogenic toxic byproducts. So I can say that currently in Lebanon, ETO is banned for the spices and herbs that are willing to be exported to Europe, but it's still used for all spices and herbs exported to United States. And here also you can see on the rapid alert system for food and feed in Europe, till now, some spices imported from Lebanon with traces of ETO. So you can see here ethylene oxide and Toshi spices from Lebanon via Netherlands, also in black pepper and in spice preparation. So here we can see a real implementation of the ETO sterilization in Lebanon. So as you can see, they put on a pallet the bags of spices, and then they apply the pellets of ETO, the ethylene oxide, in a closed chamber, and this will decontaminate the spices. So in many factories in Lebanon, they still use the manual sealing machine, but some others it's automated. And here we have actually to take this into consideration when we propose a decontamination system for spices and herbs. So passing to the new technologies, we have ozonation, cold plasma, ultraviolet, microwave, and radiotherapy. But what about the effect and the limitation of these treatments in terms of altering the volatile and flavor quality of the product? So this have to be thoroughly investigated. So after introducing the problem and mentioning the details of actually how big is the problem in terms of spices and herbs, and I want actually to highlight that this problem is not only in Lebanon, it's an international problem. So in some countries, they have adopted some decontamination techniques, but in many countries, they still have the problem and they never took action in this. So all of this make the it make the problem very big, and it's very urgent to find a decontamination technique for spices and herbs. And this is why I collaborated with Professor Ian Watson from the University of Glasgow. So he's affiliated with the School of Engineering at the University of Glasgow. And together we worked on developing a hurdle technology to decontaminate spices and herbs. So we were able till now to publish 2 papers. So on the left side, you can see the decontamination of chili flakes in a fluidized bath using this hurdle technology. And on the right side, we tested also the system on onion flakes and black pepper. I can tell you that we are still on the preliminary stage assessing the decontamination effect of this system. So in this system, we thought about combining 3 technologies: the ozone, the UV, and the infrared. So why did we choose the ozone? Because the ozone was shown to possess a very good antimicrobial agent against bacteria, owing to its powerful oxidizing effect. So it has been used for spices in different research work, and it has shown 6 log numbers of bacillus in some of the works and 3.5 log number of E. coli on paprika. We use ultraviolet because it presents as well antimicrobial effect due to the cell wall penetration by blocking DNA transcription and replication. And it was shown as well to be effective against a wide spectrum of microorganisms. And last, we use the infrared because also it possesses an antimicrobial activity owing to the surface pasteurization and to the rapid heat capacity. And some published work shown a good decontamination effect on bacillus in paprika. So this is our prototype. So I'm going to go over it. So first of all, the prototype consists of a fused quartz tube, as you can see here. So it's a 900 millimeter long fused quartz tube with an internal diameter of 33 millimeter and a wall thickness of 3 millimeter. So as you can see here on the left side, we have the air flow pump. Why do we need to flow the air? Because we need to flow in a fluidized bath the spices and herbs in this tube. I'm going to show you on the right side a video showing how do we flow the spices in the quartz tube. And why actually we decided to include this flowing, because we all know that spices are very sticky. So it's very hard actually to apply a kind of light treatment such as UV light or infrared without flowing and separating these small particles from each other. So this is why it was very important to flow them in the tube. So these air pumps, they have an airflow rate of 108 liters per minute. So here around the tube, you can see we have 2 lamps, the UV lamp and the infrared lamp. The UV lamp, it was a 4-watt lamp, and the infrared lamp 100 watt, and they were placed each other 20 millimeter aside from the quartz tube. Okay. Also, you can see here the ozone generator. So we use an ozone generator having a capacity of 300 milligram ozone per hour, and the rate used was 2 to 3 liters per minute. And you can see here a valve. So this valve, it was turned on and off either if we want to flow the chili flakes with air, or we want to flow the ozone. So we never used ozone and air at the same time. So we were manipulating this from this valve. So either we apply ozone or we apply airflow combined with UV and infrared light. So as you can see, the samples will flow inside these tubes, and we can separately or individually apply either UV alone, infrared alone, ozone alone, or a combination of more than one treatment. And this is what is called hurdle technology. When you combine more than one treatment and you benefit from the advantage of each treatment and you avoid the disadvantage of each one, because you are not applying for a long period of time. So if we unbox here, you can see more the infrared and UV lamp. So concerning the plant materials that we have used in our studies, so as I mentioned before, we tried the test on chili flakes, black pepper, onion flakes, and za'atar. I'm not going to show the data of za'atar. I just want to say that when we started the work initially with chili flakes, we decided that at the first time, we don't want to assess the effect of the decontamination system on the quality. The main idea was only to test the effect on the microbial load. So we purchased chili flakes. we fully autoclave them. When I say autoclave, means we heat treat at a very high temperature for a long period of time to fully sterilize the chili flakes. So now that the chili flakes are zero bacteria, free of bacteria, we inoculated with E. coli, okay, E. coliform bacteria, and then we pursued our treatment trials. However, for black pepper and onion, since we were willing to check the effect on the quality, so we purchased material, so we purchased onion flakes and black pepper from the Lebanese market, shown to be conform with Lebanon norm. So this is the norm adopted in Lebanon to assess the conformity of the product. So here, instead of autoclaving and losing the quality of the product by heat treatment, we decide to start with a safe matrix and inoculating it with bacteria to test the effect of the machine. So what we did initially is that we inoculated 20 grams of spices with overnight culture of E. coli at 2 × 10⁶. When I say CFU, means colony forming units of bacteria per 1 milliliter, okay? And then afterwards, we applied a drying at in oven at 35 degrees Celsius for 2 hours. Why did we apply the drying? Because we cannot flow wet spices. It's very important to dry them in order to be able to flow them in this fluidized bed inside the tube. And then afterwards, we applied a series of treatments, either individual or in combinations together. So definitely the main outcome to be tested was the E. coli load. So we pursued a series of microbiological analysis after each treatment to check the E. coli load. So this is the system overview. So before starting with the infrared treatment, we were keen on maintaining a low temperature or a moderated temperature, if I want to say, inside the tube to avoid any kind of quality defect. So first of all, we check the temperature inside the tube, outside the tube, the nearest point to the infrared and the furthest point to the infrared. And as you can see, within 2 minutes, okay, the temperature reached around 70 degrees. So it was very high on a very high temperature affecting the quality of the spices. So that's why we decided to modulate manually the infrared. How do we modulate manually an infrared lamp? Just by turning it on and off. So all through the treatment time, we're turning on and off the lamp in order to moderate the temperature. And we came up with the conclusion that when the temperature outside the tube was around 60, so inside the tube, it was about 37. And this is how we fixed it. So we were keen on all the time to monitor the temperature outside the tube to make sure that inside the tube it was 37, not affecting the quality of the spices. So I will go over some of the results that we have obtained. So first, I'm going to show the drying kinetics on chili flakes. CF is chili flakes, OF is onion flakes, and BP is black pepper over the period time of the drying. Okay, so this is the total count of E. coli over the drying time. And I can say that for chili flakes, we obtained a reduction of around 55% of the E. coli load, for onion flakes 68%, and for black pepper 78%. This is very normal, because when you lose water, definitely the water activity content will decrease and the bacterial load will decrease. So after the drying, we started with individual treatment. So here I'm showing individual treatment on chili flakes of 1 hour of ozone, 1 hour of UV, and 1 hour of infrared. And again, here we are checking the load of bacteria. As you can see in the graphs, 20 minutes of ozone and UV were enough to fully destroy the bacteria. So they are considered as bactericidal. However, for UV, we required at least 40 minutes, okay, to destroy the bacteria. And this is in concordance with the other studies who have shown that ozone effect is due to its ability to destroy a crucial part of the bacterial membrane, consequently leading to the death of the bacteria. And UV was shown to be less sufficient because it has only a shallow surface exposure. What about onion flakes and black pepper effect? Again, here I'm showing individual treatments. So as you can see, in dotted, we have the black pepper and full line. So the dashed line are black pepper and the full line are for onion flakes. So we obtained a better effect of the individual treatments on black pepper rather than the onion flakes, with a bactericidal effect of ozone and UV requiring 17.5 minutes for a black pepper. However, 30 minutes were needed for onion flakes and 30 minutes were needed for infrared for both types of spices. And this could be actually linked to the shape of the spices. So the shapes of flakes are different than the shapes of black pepper, and the inoculated bacteria could be more protected in a flake onion shape rather than a black pepper, because the ozone power is affected by the penetration depth as well as the UV power and the infrared power. So we can say that the decontamination effect is typically also linked to the type of spices. So we need to take this into consideration, and that's why we need to do more investigations of different type of spices and herbs. So now what about the combination? So after checking the individual treatments and after actually screening the literature and showing that very few studies have investigated the combination of these three treatments together, so we decided to pursue this part. And as you can see on the left side, we applied 20 minutes of ozone followed by 60 minutes of UV and infrared together. When I say UV and infrared together, that means that we flow the spice and we turn on together the two lamps, UV and infrared, and we see the effect of combination for inoculated chili flakes and for raw chili flakes. And as you can see, ozone has a dominating effect. So only 20 minutes of ozone, they were enough to destroy the bacteria before pursuing the combination. So it has a very important effect. And when we have checked in this study that 20 minutes of ozone were more than enough, we decided to reduce this exposure time on onion flakes and black pepper. So this time on the left side, we applied only 2.5 minutes of ozone, followed by 10 minutes of UV infrared combination. And on the right side, we applied 5 minutes of ozone, followed by UV and infrared combination. And here, actually, we can see that 2.5 minutes of ozone were enough to destroy 99.98% of the bacterial load in onion flakes and 99.99% of bacterial load E. coli in black pepper. Same results were obtained for 5 minutes. So again, we can say that 2.5 minutes and 5 minutes, they gave almost the same result. So 2.5 minutes of ozone were more than enough to destroy the bacteria. So this also emphasized on the bactericidal effect of ozone. So better definitely to treat for a shorter period of time because also we save energy. And here we concluded that ozone has a prominent effect in decontaminating. Now we pass to the next kind of combination that we applied. And in this slide, we wanted to check the effect of order. So what about starting with combination, then following by ozone, and then reversing the order? So on the left side, we treated with UV infrared combination for 10 minutes, followed by ozone. And on the right side, we treated with with ozone first 10 minutes, followed by UV infrared 10 minutes. And here we have actually noted a synergistic effect of UV infrared together. So when we combined UV and infrared together, they were even more powerful than ozone. So a higher level of reduction was obtained. And this emphasized on the importance of combining treatments together. Similar effect was obtained when combining UV and infrared in onion flakes and black pepper. So here also you can see that 2.5 minutes of UV infrared together, okay, followed by ozone, gave also a very good result. So almost similar or even better than 5 minutes of ozone of UV and infrared together. So we can shorten the time when we combine the treatments together. So talking about scaling up the prototype and the cost analysis. So when we conducted the cost analysis, we noticed that infrared lamp was taking the major part of the cost price-wise. So the cost was dominated by infrared lamp. And now we are wondering if it's really needed to keep the infrared lamp in this prototype, or we can try combination of ozone and UV together without the infrared. So further investigation are needed to take a decision about this. So as a conclusion, I can say that this HERDIT technology, this prototype, which consists of a combination of ozone, UV, and modulated infrared light, was shown to be very effective in decontaminating the spices and herbs. So ozone and infrared reduced completely the artificial bioburden in less than 20 minutes. However, more time was needed for UV. We can say also that we noted all through the study a synergistic effect of combined treatment. So it's very important when we combine the treatment together rather than applying individually each treatment aside. And also what was noted that depending on the type of spices, we can have different responses, specifically that we obtained a better effectiveness of black pepper compared to onion flakes. What about the future work? Now what we are actually willing to do, first of all, to continue pursuing more experiment on more type of spices and herbs to have a bigger idea on the efficacy of the treatment, as well as trying other bacteria than E. coli, maybe trying Clostridium or Salmonella or other kind of pathogenic bacteria and checking the efficacy of the treatment. Once we are pretty sure that the system is very, very efficient, definitely we need to work on retrofitting and upscaling the system in order to making it fully automated, inserted in food processing line to decontaminate the spices and herbs in factories. And also the missing part that is actually we are working on it right now is to assess the effect of this herd technology on the color and flavor of the spices and herbs. So basically on the quality of spices and herbs through a thorough organoleptic assessment. Thank you so much.
Many thanks, Dr. Nada, for this interesting topic. I am Zakaria Rajab, Assistant Professor at University of Benghazi, Electrical and Electronic Department. Also, we need to increase our thanks to AGYA for their support and sponsor this conference. Any question?